Hi, I'm Machindanale. I'm one of the architects working on CA Mainframe Operational Intelligence here at Broadcom. Today, I'm going to talk about issue intelligence and how this capability helps system DBAs to find out issues faster in DB2 environments without manual correlation of alerts. CA Mainframe Operational Intelligence, also known as CA MOI, is an AIOps solution. It collects the operation data from your various subsystems by tapping on the existing monitors like CA SysView, NetMaster, Vantage, DB2 Detector, and so on. It can also mine SMF records. Once the metrics are collected in near real time, it builds the baseline for each metric, identifies the seasonality, and predicts the future values of the metric. If the metric dispatches from the expected value, it flags that as an anomaly. These anomalies are surfaced without you defining the static thresholds. On the top of these anomalies, yet another machine learning algorithm called alert clustering is performed to group them together to produce even higher level of insights. These insights, along with the context, now can be fed into your automation tool to take the corrective action. The whole system is designed to get you ahead of the issues. Today, the focus is on the DB2. CMOI can collect the operation data from the CA SysView for DB2, CA detector for DB2, or also can mine it from SMF 101 records. These metrics are collected at the plan, package, as well as at the system subsystem level. These metrics, which are collected at near real time, are now fed into anomaly detection engine to surface anomalies. These anomalies undergo automated pattern discovery, what we call it as issue intelligence. This machine learning algorithm tries to find out a pattern in the metrics which are correlated, and hence cluster the alerts together to surface higher level insight called issue alert. This issue alert is comprised of member alerts, perhaps capturing the symptoms and root causes of a particular situation. This algorithmic way of grouping alerts together prevents the alert fatigue and also reduces the workload of IT operations team, as they do not have to spend time manually correlating alerts to find out the situations again and again. Now I will demonstrate how this issue intelligence helps system DBA Bob to identify issues faster in his DB2 environment without wasting time on the manual correlation. I have logged in MOI user interface. This is a demo system. It's not running production workload, but helps in conveying the possibilities with MOI to detect similar situations in the real world. In this alert panel, there are a number of alerts surfaced. The very first alert is about catalog, and there are a bunch of alerts related to the DB2 plan and packages, and there are a bunch of other alerts with respect to DB2 subsystem itself, and some of them are related to CICS and so on. It takes a lot of time to manually correlate these alerts and see if they are part of the same situation. It's not only time consuming, but it is harder to find out such situation. Hence, let me switch it to issue intelligence view and see what machine learning has found for Bob. In this, I find an issue alert surfaced with a high severity. Clicking on the issue alert opens up the member alerts of that particular issue. The alerts are arranged in the descending time order. So the latest is surfaced at the very beginning of this issue alert. So let me go down to the bottom of this issue and see what problem it is indicating. The very first alert here is about CICS region, and looks like the CPU usage is high at 419, and you can see the spike on the chart indicating the higher CPU usage. The next alert in this issue is talking about the total CPU usage for the same CICS job, and it has also spiked at the very same time. The third member alert of this issue talks about the number of threads created in a DB2 subsystem called DC25, and apparently there is a spike at about the same time. The next alert talks about CICS, and this is CICS address space where the job IO per second increased at about the same time. The next one in the list is talking about the total number of SQL statement executed in the DB2 subsystem called DC25, and looks like there is a spike found around the same time. The next thing that we want to find out, who is executing those SQL statements. The next member alert talks about the number of commits and aborts happening in the DB2 subsystem DC25, but these are the CICS connections. Now we know that the very time the CICS transactions are coming in into DB2 and possibly causing high number of commits and abort about the same time. The next member alert talks about a CICS region, CICS 253, which is running a CICS transaction called EGUI, and the number of transaction count of this particular transaction went up high at the very same time. Perhaps this could be the culprit CICS transaction, which is executing huge number of SQL statements in the DB2 subsystem. Now let's continue watching other member alerts. The next alert in the list is number of lock requests for DB2 subsystem DC25 spiked around the same time. Then the number of get page requests for a buffer pool called BP2 in the DC25 subsystem spiked around the same time. The next alert is about CPU usage on the LPAR, and apparently the general processor usage on DE25, where this DB2 subsystem is residing, spiked up. Now let's go over the rest of the member alerts. So DB2 other time at the same time spiked up. The DB2 other time for all connections seen a spike at the same time. The number of transactions for the CICS region increased. The read IO for a buffer pool in the DB2 subsystem increased. The CPU usage on which this DB2 subsystem and CICS resides also increased. Now we learn how this issue alert has captured all the indicators from the CICS regions, the DB2 subsystem, the culprit CICS transaction, and the LPAR resources, all put together into one single situation to look at. If this issue is helpful, then you can reward the machine learning by clicking on the like button, or click on the dislike button if this issue alert is not helpful, so that this issue alert will not be surfaced in the future. These issue alerts now can be fed into your automation tool via WTO or CA Ops MVS integration. The annotation tab helps you collaborate with your fellow operation team to provide the comments right on the top of the alert. Now we learned how CA Mainframe Operational Intelligence uses machine learning to correlate alerts automatically so that you can focus on your most important task and let the machine learning identify situations for you. Thanks for your time.